Now we move from theory to real aircraft case studies, where we will see how structural principles are applied to solve actual safety and reliability issues. This case study highlights a material non-conformance issue in the aft cargo barrier fitting links of the B787. These fittings are load-carrying structural components that help transfer loads within the cargo compartment structure. During production, it was discovered that some fittings were manufactured using an incorrect titanium alloy instead of the specified aerospace-grade titanium 6AL4V. Although the geometry and installation of the fittings were correct, the material itself did not meet the approved structural specification. Since different titanium alloys have different strength and fatigue properties, using an incorrect alloy can reduce the load-carrying capability and long-term durability of the part. To address this unsafe condition, the AD required inspection and material verification using approved methods such as XRF or HFEC to confirm the alloy type and replace any non-conforming parts. This case study clearly shows that in aircraft structures, material specification is as critical as design and dimensions. Even a small variation in alloy composition can significantly affect strength, fatigue life, and structural reliability. Aerospace components must meet strict material standards, and proper traceability is essential to ensure the correct alloy is used during manufacturing. The AD reinforces the importance of supplier quality control, inspection processes, and verification methods to prevent incorrect materials from entering service. The key learning from Module 3 is that structural safety does not depend only on shape and size, but also on precise material selection and control throughout the production and certification process.